Hi people, this is Mete from codingmac.com. Uh, for a while I've been a little lazy and a little busy in the work, but lazy in the community content. Uh, I've been working on something and I've prepared the software, so I would like to share them with you. So I'm starting a new video series which is named Querying Social Media and Public Information. So the part one of this series will not be about querying uh, like Twitter, Facebook, social media as you expected. It will be about querying the Z39.50 protocol, but uh, in the later episodes, I will show you how to query Twitter, Instagram, and Google API. But now we will start with Z39.50. So let's see what is Z39.50. So it's an applications layer communications protocol. In fact, it's a little old, and it's a pre-web technology. And if I'm not wrong, it was invented in 1970 or so. And uh, actually, it's an ANSI standard, which is called with the same name, and it's an ISO standard. Uh, if you replace the Z with two, the ISO 23950 standard stands for Z3950, and it's maintained by the Library of Congress. It's released and maintained, and I will show you its website. And it supports SQL or PQF queries, and I will show you how to query a data source. And it has different implementations. So as a summary, what are we doing? What are we trying to do? We will be querying libraries. Libraries of what? For example, Oxford Library or MIT Library or anything at Aberdeen University. So most of the universities have public libraries which are queryable from the internet, and they are using this kind of legacy protocol for supplying information. So we are querying the libraries and we are getting book information from them about the author, etc. And let me show you the website of the Congress, so the information will be more concrete. So this is the Congress's webpage, which is the gateway to the library catalogs. And you can see from here there are huge number of libraries, and there are a lot of libraries here listed. But in fact, there are libraries which are not listed here. So if you are wondering to query a library, uh, you can first look at here and try to query it. And if it's working, you can use, or you can directly contact the university or that library. For example, it can be a state library or I don't know, any public library. So yeah, you can directly contact them and ask for their details, and most probably they are supporting Z39.50. So uh, if we search here like Oxford University, uh, um, well, let me, because I always fail to write Massachusetts. Yeah, yeah. Oop. Yeah. So MIT is here. For example, I've seen Duke University, or yeah, there are a lot of universities here. And uh, the statements in the parentheses, as you can see, InnoPack, Horizon, Cersei, Dynix, uh, InnoPack, Voyager. So these are the different implementations of Z39.50 protocol. So uh, it has some standards, but there are different implementations of those standards which affect the data and metadata structure which comes after you query the data source. Um, so that matters a lot because uh, if your software will not is not supporting that specific implementation, it will be an issue. So uh, you should first try to query that implementation, and maybe in your software solution you will be querying multiple libraries. So you can choose the same implementation of Z39.50, for example, or you can just try if your software supports the implementations that you will use. If it doesn't support, then you can add the support to those implementations also. So you can go with this strategy. But you should keep in mind that there are different versions of data and metadata which is coming from Z39.50. So let's return to the demo, the slides. Um, so here is how our application will work. We'll be using yas.dll, which is an unmanaged DLL, which is not .NET library. So there's an implementation which wraps the yas.dll, which is called yas sharp, or it's also known as zoom.net library, and it kind of wraps the yas.dll and other unmanaged libraries so that we can query Z39.50 from our .NET application. And by consuming this, we will be querying the Z39.50 endpoint and getting the reply, and then transforming it to an object. And in that object, each result will exist as an XML string. So what I will do is transform each XML result and combine them as a single XML string, or you can do the same thing as transforming them to a single HTML and then display to the user. So let me show you the sample application that I've developed, and you can also reach it from this URL from my GitHub repository. You can just reach it, and there's the DLLs also associated with it, so you can directly use those DLLs, because it was a kind of pain to find the correct versions of them, as the Zoom.net project doesn't seem to be alive anymore, and the technologies are pretty old. So I had that pain, and you don't need to. So let me switch to my Visual Studio. So there are some key things to consider here. The first thing is the DLL. So we don't have the yas sharp or zoom.net as a NuGet package. So I found the correct versions of them. For as mentioning the correct versions, the project zoom.net has a SourceForge site, and in that site I navigated to files here, and from there you can see it's the last version was uploaded in 2006. So that's what I'm talking about. And this seems as the latest version that I could find on the net. So the DLLs in the sample project were taken from here. So you can also come here and download the files. I will provide you all the links about this video. Let me continue. So I placed all the related DLLs to here. These two are .NET DLLs, managed DLLs, and these are unmanaged DLLs. Uh, so uh, these are I've looked to the source files of this project, and these are referenced by DLL import statements, and these need to be at the same folder with the managed Zoom.NET and Zoom.NET YASSharp DLL files. So in order to do that, when we reference these two files, you'll see I referenced them from the reference DLLs folder. When we reference these two files, they will be automatically copied to the bin folder when we build the application. But these DLLs will not be copied, and then we will have a problem. So in order to overcome this issue, here under build events, I added some events to copy the files to the target directory. So when we build the application, then those unmanaged DLLs will also be copied to the bin folder, so that the managed DLLs will be able to import them successfully. So right, let's continue. And there's another key point here. If you're using, probably most of you are using either Windows 7, 8, or 10. These are the missing DLLs, the missing Visual Studio C++ DLLs in those versions of Windows. They don't exist by default. So these two files also need to be added to either syswow64 or system32 folders in your file system. It depends, either you're building a 32 or 64-bit application. In order to guarantee it, just copy them to both of these directories, Windows/system32 or Windows/syswow64. So after we do that, after we do the DLL copy configuration plus copying those required DLLs to the system folders, we are set, and now we can implement our application. So in the sample application, I just created a literal that will render the details of the book. So it will render what I provide to it. I will just provide an XML string to it, but you can provide an HTML, then it will be rendered quite user friendly. So XML is not a user friendly approach. So what are we doing? So the first thing is, in my demo app, I'm connecting to Library of Oxford, and these are the details I gathered from the Library of Congress site. And the three things that I have to know are the address, the URL, the port that I will connect to, and the name of the database. So how can I find them? Let's go to here and type Oxford. So this page is not only for displaying the connection information of each library, but also it is for querying each library. So when I click it, now I can enter the terms, for example, the title, let's say Kennedy, and It can be a single word or word list, or I can add other terms like I don't know, author, ISBN, or I can use logical operators. So these come from the nature of PQF queries or CQL queries, and the CQL or PQF query support may depends on the implementation of Z39.50. So the thing that I the thing the only information remaining is here. You see the URL plus the port. So the only missing thing is the database name. So in order to get it, I will just say view page source, and here we have the DB name input field, and it says advanced. So by doing that, I can get the DB name. So I got all the information that I need. So the URL plus the port and the DB name. So by default, I'm setting this syntax to record syntax XML. I haven't tried any other variation. So you can try yourself. So I'm creating the connection, then then I'm running the connect method of the connection. It's connecting. Then I'm running a query, a PQF query. So this query means attribute 1 is equal to 4 and Kennedy. So this means I will be searching through the title which contains the keyword Kennedy. So as a caveat for you, you can also use the source code here about the terms. For example, use 3 for title, or you can see, you can return back to here. Attribute 1 is equal to for Kennedy. So let me just return. So this is attribute 1 is equal to 4 means title in this implementation. So I requested details of a library in my own country, and they provided me a list of the attributes that I can use in the query. So either you can get them from the library when you request it, or you can go to this list and learn which which attributes to use and how to create the library, or you can refer to any documentation of PQF or CQL about how to query those libraries, and you can just try it yourself. Okay, then I will be searching the keyword Kennedy in the titles of the books, and I structure it as a prefix PQF query, or you can either select CQL query if the implementation supports it. And then I will getting the results, and this is for performance. What I'm doing is I'm setting up a limit to the maximum number of results to be rendered, because suppose there are 1000 or 100,000 results, and it will take time to render all of them. Then what I'm doing is, this is the string that is coming for each result. This is the XML string, and I'm transforming it to my XML format. So this is, I'm doing an XSL transformation here. I've structured this file by using Altova tools, and it's not pretty important. You can use your own format. So what I'm doing is I'm mapping the information from the XML schema to my own XML schema, and I'm transforming it to my own XML format. So this is where the implementation Z39.50 implementation matters. according to the implementation, you need to map different fields to the corresponding schema of yourself. So then, okay, I'm kind of lost. Then I found the right place. Okay, then transforming each result, I'm just replacing that XML header, because after transforming, this is automatically added to each result. Then after replacing that, I will have a single XML string, because UTF-16 always causes trouble, you know. Visual Studio automatically adds it, so this is not a best practice, but it works. Right, so let's see how this is running. So this is the transform method that I copied and pasted from somewhere else. It's already working. So let's see how the thing works. Let's wait a little. Yeah, the results came, and you will notice here all the dates are set to 2003. The reason to that is they're coming all right from the data source, but I'm the format of the dates were not correct according to my schema, and I was just lazy. I didn't want to work on just transforming it to my format, and I just chose to insert a constant value to there. Here you can see there's a constant value in the transformation XSLT, so this is why. And let me return. Those are the live data that we got from the Oxford database. So let me show you by debugging in the for each statement. Oop, I'll come to here, yeah. So I have, as I've limited the number of results to 100, I have this one. So how many? I have 1,501 results. So I've limited the number of results to 100. And in each content string, so yeah, get string. I need that one. Oop. Immediate window. Yeah, you see, so each result comes as an XML string. So what I'm doing is I'm transforming each of these XML strings, and I'm just removing all the unnecessary information from here, because it also contains the schema information of the XML, etc., and I'm removing all of them, and I'm just merging the whole information as a single XML string, and then I'm just sending it to the screen in order to be rendered. So that's all. It's been a while. Sorry, I was planning this video a lot shorter, but I hope you enjoyed it, and I hope it's useful. So for the information and related links, please visit codingmac.com, and also in the YouTube video details page, I will be sharing all the links and related resources, etc. So thank you very much for watching and listening. See you in the next part of the series. Bye bye.